let's sketch out the Lewis structure of CCl4, commonly known as carbon tetrachloride. We'll use these simple steps to accurately depict the Lewis structure of CCl4. First, we'll sketch a rough diagram of the structure. Next, we'll use electrons to represent the chemical bonds between the atoms in CCl4. Then we'll identify and mark the lone pairs on the respective atoms, ensuring that each atom satisfies the octet rule. Finally, we'll calculate the formal charges for each atom in CCl4 and verify the stability of the final structure. To draw a rough diagram of CCl4, we first need to calculate the total number of valence electrons and then identify the central atom. The total number of valence electrons in CCl4 can be determined by summing the valence electrons of each atom in the molecule. Carbon, a group 14 element, has 4 valence electrons, while each chlorine atom, belonging to group 17, has 7 valence electrons. Since CCl4 consists of 1 carbon atom and 4 chlorine atoms, the total number of valence electrons is calculated as 4 plus 7 multiplied by 4. Simplifying this gives 4 plus 28, which equals to 32. Thus, CCl4 has a total of 32 valence electrons. When determining the central atom for CCl4, the element with the lower electronegativity should be placed at the center. The electronegativity values of carbon and chlorine are 2.55 and 3.16, respectively. Since carbon has the lower electronegativity, it is chosen as the central atom. Therefore, the rough sketch of CCl4 should have a carbon atom at the center, with the 4 chlorine atoms arranged around it. 2 electrons represent a single chemical bond. Therefore, we will place 2 electrons between carbon and each chlorine atom to represent 4 chemical bonds. In this way, we have used 8 electrons to form these bonds, leaving 24 unutilized from the total of 32 valence electrons. Lone pairs consist of electron pairs that are not involved in chemical bonding. It's important to remember that a single lone pair consists of 2 electrons. Since we have 24 unutilized electrons, we can form 12 lone pairs, which can then be marked on the structure. Another point to remember is that carbon is a period 2 element and cannot hold more than 8 electrons in its valence shell. In contrast, chlorine, which is a period 3 element, can accommodate more than 8 electrons in its valence shell. Another key point is to always begin marking lone pairs on the outer atoms before proceeding to the central atom. In CCl4, each of the 4 outer chlorine atoms is assigned 3 lone pairs, while the central carbon atom does not receive any lone pairs. This is because there are only 12 lone pairs available, leaving none remaining to assign to the central atom. We can observe that the octet is complete for the 4 outer chlorine atoms as well as for the central carbon atom. Now we will check the stability of the structure by calculating the formal charges for each atom. This is the formula we can use to calculate formal charges for the CCl4 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Enter the required data and insert the values to determine the formal charges for each specific atom. For carbon atom, valence electrons equals 4, non-bonding electrons equals 0, and bonding electrons equals 8. So, the formal charge will be equals 4 minus 0 minus half multiplied by 8, which equals 0. For each chlorine atom, valence electrons equals 7, non-bonding electrons equals 6, and bonding electrons equals 2. So, The formal charge will be equals 7 minus 6 minus half multiplied by 2, which equals also 0. The formal charges of the carbon and chlorine atoms are indicated, and it is clear that none of the atoms in the current CCl4 structure have any formal charges. Therefore, this structure can be considered the stable Lewis structure of CCl4. To represent a bonding pair, we draw a single line between the atoms. In this structure, there is one pair of electrons between carbon and each chlorine atom, so we draw one line between them, indicating that carbon is single-bonded to the 4 chlorine atoms in the CCl4 Lewis structure. So, that's the Lewis structure of CCl4. If you found this breakdown helpful, press the like button, share the video with your pals, and subscribe for more chemistry knowledge.